Hello and welcome to my screencast on irrigation. This screencast is being used as part of the VCE Biology Unit 1 course and relates to various forms of irrigation in agriculture and horticulture. There is a huge amount of information and statistics available on water use in Australia and the various industries that make use of it. I'm not going to go into that. We don't need to memorize that sort of thing for any exams. But the most important fact to know is that our region, the Murray-Darling, right down in the bottom corner, let's circle it there, we have very heavy water use in this particular region. They do have more water use further north up in Queensland as well, but they tend to have a lot more rainfall in those areas too. The Murray-Darling region is comparatively dry, so the irrigation water used here comes out of the rivers. The industries that do use the water tend to be the ones that are much higher value. The ones listed down the side, vegetables, fruit and cotton, are the biggest. There's also a certain amount of dairying done, and it's also used in some cases for the irrigation of fodder crops for dairy cattle too. Now, water from the Murray River is allocated. Those allocations are bought and sold, they are tradable. So farmers that require a great deal of water for their particular business are able to buy water allocations from farmers that don't need it. This is a very simple market model that allocates the water according to who's willing to pay the most for it. The water in this case can either be high or low reliability. High reliability is water which is unlikely to see its license revoked in any 1 year. The low reliability water, there is the possibility that if there isn't terribly good flows in the Murray River, that the Water Authority may prevent farmers from using that. The high and low reliability water will have different prices, and some farmers will have more of one than the other, depending on whether or not they either have the money or the farm model, which requires large quantities of reliable water. Irrigating a farm is really expensive. It's not just the fact that you have to have equipment to be able to irrigate the farm and infrastructure on the farm to be able to move the water from one place to another, but you need to also have the allocation for that water, which can cost many thousands of dollars per megalitre. And also in some cases you need to pay for the electricity or the diesel to pump that water from one place to another. So it's a considerable cost to farmers that use it, and as a consequence they need to be in a farming industry that is going to give them a return on that money. There's no point using huge amounts of water and huge amounts of money to produce something that's low value. Hence, if you think back to the previous slides, it tends to be seen more in high value industries like horticulture and dairying and cotton as well. Because of this extra cost involved, farmers need to make sure that they use that water as efficiently as possible. They're not going to apply it to their paddocks unless their paddocks are set up for it, or they're going to require expensive equipment to apply it. The top picture is of a paddock that's being laser leveled, and this is where the water is being introduced at one end of a paddock through a sluice gate, and it floods that paddock, usually to the depth of about 40 or 50 millimeters at most, and then that water is then allowed to seep into the soil and water the plants. The bottom picture is a travelling irrigator. The one in the picture here is particularly large, and the water for this would need to be pumped. They would either have large diesel pumps or electric pumps to pump the water right the way throughout this very large piece of equipment, and this would then travel across the paddock and sprinkle the water as it goes. If we zoom in on the picture here, we can see that we have a long line of sprinklers. If I just circle one here, and they sprinkle the water out. Let's put some diagrams on. Here we go. They sprinkle the water out like so. Now, as it's travelling along through the paddock, these wheels are turning as well, and they will be moving the whole system from one end of the paddock to another and sprinkling as it goes. So it'll be putting on a considerable amount of water as if it's raining. Another form of travelling irrigator is the one in the top corner. This one has a large impact sprinkler on a stalk which fires quite a lot of water quite a distance, and this one also moves across the paddock in a direction like so. There's a cable that it runs along, and the flow of the water actually turns a motor which gives the irrigator the ability to move. The middle picture is of a static sprinkler, which has lines buried in the ground, and this would be part of a network of other sprinklers which cover the whole area. You can see it's quite a high value crop here. It looks like lettuce being grown in the ground. The bottom picture I've added because irrigation is not only used for watering plants. The bottom picture is of a vineyard, and the sprinklers that are over it would serve two different purposes. Not only would they water the plants, but they would also provide frost protection. If you have liquid water on plants when it's frosty, the plants themselves won't freeze because the water absorbs, or the water gives off energy to the plant and stops it from freezing. So if it's going to be frosty when the plants are flowering and you don't want to lose the flowers, then the growers will put sprinklers on. A big downside to using sprinklers over things like grapevines is that you dramatically increase the humidity around the plants, and this can lead to fungal problems. So the growers might then have to go around afterwards and apply sprays to keep down the fungal spores, which would start germinating once they get humid enough. One of the newest and most modern ways of irrigating a crop is using the equipment in the top picture. This is called a self-compensating inline dripper. And these are within the thin wall pipe itself. They allow a measured amount of water to come out through the hole. Let's just indicate that hole there, that little hole there. The rectangle that's cut out is actually looking inside. And what it does is it creates a turbulent flow of water. So all those wiggly bits with the blue lines in them, they slow down the water. And this means that you get the same amount of water coming out of the pipe right next to the pump and perhaps 50 or even 100 meters away from the pump. If you didn't have the self-compensating, which means that the compensating is for the pressure, if you didn't have that, you would have water squirting out under quite high pressure close to the pump, and you would have barely a trickle coming out a long way off. So this is a very clever way of enabling farmers to have uniform water output throughout their crop. They tend to be used on quite expensive crops, things like grapevines, which is the middle picture, and they would also be used in things like orchards. There are now cheaper ways of putting inline drippers into pipes, so there are some cheaper forms. And one use that's being put to is subsurface irrigations and things like dairy farms. This is put into the ground. It's actually buried in the ground. If we zoom in the picture at the bottom, it's being put into the ground here by a modified mole plough, and the pipe comes down through the plough itself. And when this plough, they're sticking out of the ground a little bit more than they would be at them when they're in use. Normally they would be buried down to about 300 millimeters. And these lines are trailed out by these mole ploughs. They come out of a hole at the end there and are left behind in the ground by the mole plough. Once that's in place, then as long as the farmer doesn't do anything like ripping this paddock and effectively chopping up all of these lines will stay in the ground for quite a long time. It's possible that some of them may get squashed because of pugging in the winter, but generally they're very good. It's just an expensive way of doing it. But as long as the farmer is able to get a return on the money that he's spending, then it's a distinct possibility. He also needs to have the right soil type for it. A very sandy soil will see the water not spreading very far. This would work very well on more clay and silty soils. Greenhouse crops tend to use drippers quite a lot. They don't tend to use huge amounts of water given the amount of money that's being produced from them. Most of the money required in greenhouse crops is for the greenhouse itself. The drippers that are in the top picture, and I'll just circle one of them there, this will tend to put out a spray which will wet all of this, the potting mix, or the potting medium that's in there, and the potting medium that's in there is actually coconut husk chips. And once it's wet, then it'll stay wet for quite a while. The beauty of things like this is that you're able to cover quite large areas within the pot, and you're able to very precisely measure the amount of water that each one of these plants gets. The other thing that greenhouse crops would do alongside the irrigation is providing nutrients to the plants as well. And if you look at my plant nutrient or plant nutrition screencast, I'll talk about it a little bit more. The picture at the bottom is NFT, and that's the nutrient film technique. And basically this is a tank of nutrient solution down the bottom, which is pumped up to a channel. Usually it's something as simple as a plastic gutter. And it then runs along the bottom of that gutter, past the bottoms of the plants, wetting them on the way, and then draining back down into the reservoir. And it just pumps constantly, 24 hours a day. And this provides the plants with all of the water that they need, and in many cases will also supply all of their nutritional needs as well. As for what the future holds for the irrigation industry, well, it's only going to get more complicated, and it's only going to get more high value. As the crops that farmers are growing increase in value, some of them do anyway, the value of the water that they're applying is also becoming much more expensive. So to get the best value from it, farmers need to be using it with a lot more discretion. So the technology that they're going to start having to employ will be almost measuring it a bit like the application of fertilizers and seeds through computerized seeders. It may be possible to map a paddock and determine areas that have different soil types and water them differently using a traveling irrigator. It's also going to be used an awful lot more in things like the nursery industry, where plants will be precisely watered, either overhead or using drippers. But most of that technology already exists, but in many cases it's just so expensive that it's not worth farmers using it yet. But as the value of water increases, it becomes more and more likely that it'll start being used. That brings us to the end of this really quite short screencast. Thank you for listening.